Hello everyone, and welcome to another Bonitron training session. Today we're going to be covering UPD products, specification and configuration, UPD being uninterruptible power for drives, and that will become a lot more clear as we go along. I'm Tim Smith, the Global Sales Director for Bonitron and also the UPD Products Manager. So to start things off, a little about how we categorize our products and why we want to use UPD products and when to use UPD products. If anybody's having trouble hearing me, go ahead and IM me back, and hopefully that won't be a problem. So Bonitron categorizes their products under the umbrella of UPD products, or under voltage products, and that includes ride-through, the energy storage, and all the products that go along with it. Okay, moving along. And that's basically what we're going to focus our discussion on today, but more specifically on specification and configuration and when and what to use. This is a technical presentation, but there are economical considerations when you're specifying UPD or ride-through products or uninterruptible power for drive products. Usually a customer is going to be having utility power issues or interplant issues that are causing a loss of AC line to critical process variable frequency drives, meaning drives that can't have any disruption in their process, which would cause a disruption in the motor, which would cause problems with the manufacturing process and downtime. So when you're specifying UPD products, you have to keep in mind the balance of, how much, what are the losses in dollars, and covering the specification to a certain level, and what the cost of the equipment in relation to the losses or the benefits that the critical process end user is going to have. So hopefully that'll become much clearer as we move along here. But here's some of the issues that when you walk into an end user that's having utility power problems that are killing his drives, here's some of the things you're going to look for and quantify with them. It is a process level solution, so there's redundancy involved in a lot of cases, which I'll detail a little later on here. But the main issues that the customer's dealing with are lost product revenue, especially when the product is very expensive or a high-tech product such as semiconductor wafers. Of course, non-productive personnel. Operators are standing around waiting for the machines to come back up. And in a lot of cases, for example, robotics, broken tool repair, meaning sometimes when a reference is lost or something, possibly a robotic arm can swing around and cause personal injury or damage to the equipment. And then, of course, there's the repair issues when the equipment is damaged, and just even if things aren't damaged, restarting some applications can take a long time, which means long downtime, which means production losses. Just in general, the first thing I want to throw out to you to keep in mind when you're trying to define what type of UPD or ride-through your customer needs is the specification coverage, which is defined by the power required and the time. In other words, all of our UPD products are rated in kilowatts. We can convert from amps and horsepower, of course, but you're looking at how much power you have to apply and how much time you're covering for the customer when they're having a utility power event. Now, we were talking about some of the causes for ride-through, and one of the main things is utility power events. So it's kind of on the end user to define what type of utility power event he's having. Regionally, it's all different, depending on the country, depending on the grid. And so hopefully he knows a little bit about what type of sags or full outages he's having. So, but of course we can help him get to that point. We've been doing a lot of this stuff globally, so we know what a lot of the power quality is already in certain areas. So we can help with that, because a lot of times you won't get that information. So, and the standard solution out there right now is UPSs, and UPSs are always overkill for a lot of drive protection. Okay, here's a small power quality problem. That's also, I guess you could consider that a Tennessee power quality problem. Here's a much bigger power quality problem, but here's some of the things you're going to run across that customers are dealing with. And then we have the classic. And basically these events will take out the utility power for long periods of time. So usually when it's a sag, it's a switching issue or something like that. Then also you have internal plant events too. System and drive fault settings sometimes aren't quite right. So in other words, there's phase loss detection, which can interfere with the ride through. That's fairly rare though. Usually we don't have any issue with that, but that's why we like to know what the drive type is and what the application is, just as a double check. So now one of the things you're going to deal with is interplant redundancy. In a lot of critical applications, they'll have a plant or distribution point UPS, and then they'll also have a gen set. So those are good things to know, because that can help to define your specification as to what kind of ride through or how long you need to cover. For instance, a lot of the specifications we cover are usually when a total loss of utility power happens and they're trying to bring up a gen set. So it's the specification of total AC line loss to gen set up. Generators vary, gen sets can vary. The normal spec is usually 15 to 30 seconds. So if they've got a gen set they're trying to bring up, we can bridge the gap between utility power off and gen set up. And that we would do at the process level, which is the yellow box there that says UPD. Now that's just backing up the drives. It can back up multiple drives on a common bus too. Now there's a lot of ride-through solutions out there, and even drives have some little bit of ride-through in them, but usually not enough to cover most of the utility power events you're going to run into. For example, in the United States, most of the specifications we see are just a partial AC line loss or sags, and it could be one phase and the other two phases remaining or degraded. But as long as we have 60% remaining, then we'll back it up with the DC bus ride through. Some of the other solutions out there are UPSs, AC line sag correctors, and then also in some applications you have motor inertia too. Not all. Pumps, no inertia there, but fans, you do have inertia there, for example. Now, a lot of the ride-through solutions that are competitive in some cases to Bonitron are what we call series solutions, and those include active drive front ends, which will compensate somewhat for ride-through, series sag correctors, such as soft switching products like that, and then double conversion UPSs. These solutions are good for some applications, mainly the ones that you can't connect to the DC bus. And then also you have something called kinetic buffering, which some drives have, which they pretty much will adjust the volts to hertz to whatever the motor's doing, and when it's slowing down, so it doesn't completely lose power and shut down. So it kind of compensates for the loss of the line with internal software and things like that in the drive. But once again, that's not good for critical process ride-through, because the goal of critical process ride-through is no change in speed or torque of the motor. Now this is the main difference between the Bonitron ride-through or UPD products and some of the AC series solutions like the UPSs and the sag correctors. We're a parallel solution. The simple sag units to where you haven't added energy storage because you're still using part of the AC line remaining is a single unit that connects to the DC bus of the drive and the AC line, and it's parallel, so it doesn't affect the drive during normal process. It just sits there and waits for the threshold to dip enough to where it will activate the ride-through unit. The ride-through will use the remaining AC line, and it will boost the DC bus up to where there's no change in speed or torque of the motor. Then if you look at some of the efficiencies or how well it uses the power that it's being applied to it, you see a double conversion online UPS is 93%, and the name says it all, double conversion, AC to DC, DC back to AC. There's going to be some losses. And then you look at the series sag corrector, which is a little bit better, but once again, series solution is going to have some losses, 98%. And because we put solid DC into the bus, we're at 99% efficiency. So there's several other advantages to using DC bus ride-through. And once again, these are some of the economical considerations when you're trying to specify and figure out exactly what the customer needs. It's not as difficult as it sounds, but there is something to it. Now, we basically classify our ride-through or UPD products into three categories. And the first one, it can be a single unit only, doesn't require any multiple units, and it's just for sag correction. We had published up till this last year that it will do 50% sags. Now what that means is all three phases we have to have had 50% remaining. Then we did further testing. Now we can take it down to 60% sags. So that means 40% of the AC line must be remaining to be able to use the sag ride-throughs. We can handle a 100% single phase outage as long as there's 70% remaining of the other two phases. So it's cumulative across all three phases, and if the customer is experiencing sags and they can quantify the sags, this is a simple unit to use, and we'll get more into that as we go along here. Then the second category is what we call short-term outage, or this is 100% AC line loss. So it's usually caused by utility switching or load deviation. It's much more infrequent than sags. Sags are going to be anywhere from 95 upwards to, especially in the United States, those are going to be your main power quality under voltage events are going to be sags. If you correct for sags, a lot of times you've saved the customer enough money to balance out the cost and show some benefit too. Energy storage, when you add that gets more expensive, and now that's what we're talking about with the short-term AC line loss. 100%, all three phases gone. Now what we've done is we've taken the sag ride-throughs, the single unit ride-throughs, and we've added energy storage to them. Either electrolytic caps if it's very low kilowatts, or ultra caps for the higher kilowatts and the higher times. Ultra caps, we usually say half a second to 2 seconds if we're using the sag booster. And that's how we define short-term outage. It's not really an industry term, it's pretty relative. It just is defined by the types of energy storage we use. And now we're going to move on to long-term outages, which once again, 100% AC line loss, but this is for a longer period of time. Greater than 2 to 5 seconds, and the reason we put the two numbers in there is the 2 seconds full AC line loss, we use the sag ride-through, but it's limited to only 2 seconds because of the timing of the sag ride-through unit. It will time out in 2 seconds. But we can use ultra caps between 2 and 5 seconds if we use the heavy duty or battery booster, which we just started doing this last year, and it's working out really well. We've had a couple applications with that. But anything greater than 5 seconds, we still use valve-regulated lead-acid batteries. There's nothing special about the batteries. You have to make sure it's going to provide the correct amount of amps. So, but I wasn't going to read all that to you. This will be provided on the website. You can go back and look at the information to review it. There's a lot of information all at once here. So, this is a good reference for you that'll be on the internet. Now, UPD DC bus backup. Once again, critical applications, and the key is if the process or the whatever the end user is providing or manufacturing, during the process, if there can be no motor torque or speed deviation or interruption. And that's usually where we see most of the ride-through applications. If you're making nuts and bolts, you can turn the drive back on again. Not a big deal. But if you're making something expensive like semiconductor wafers, that can get pretty costly if your clean room environment's compromised because of change in speed of the air handlers or the chill water pumps or things like that. Once again, it's a parallel connection, and the ride-through system can be figured for the local utility power. And what we mean there is we have kilowatt steps, but we actually size the energy storage to the exact specification. The benefit there is most of the time when you're specifying a UPS for this type of application, you're pretty much stuck with minutes of batteries as opposed to possibly needing only seconds of backup. So there's a definite cost benefit there too also. We will connect to any VFD with DC bus connections. We're pretty much drive blind. But as I said earlier, it's good to know the brand of the drive. There's been a couple that have thrown us curves, but the 16 years I've been doing these applications, I've only ran into it a couple times to where there were parameters in the drive that had to be either disabled or reset. We also have been promoting a new type of solution, which is called UPD Light or partial power ride-through. Possibly the customer is only concerned with getting the process or the equipment to an orderly shutdown or zero position or whatever term he's using. And good example of this is with robotics type applications. Sometimes you don't necessarily want to ride through the event when there's a utility power outage. You just want to bring the equipment back to zero position so it doesn't damage the equipment or cause an unsafe condition for operators. What this means is that you don't have to size the ride through for the total power required, and you just have to find out what the drive takes to go through its orderly shutdown, which would be partial power from what the actual drive rating is. So I don't talk about that too much right here. Those are special engineered solutions, but if you do run into someone that starts talking about orderly shutdown or bringing the equipment to a controlled stop, there's a possibility that we wouldn't have to use such a large ride-through solution, or as long a time as could possibly be required to ride through events as opposed to shutting it down. Now this shows a simplified drawing of the three types of ride-through solutions that we provide, and these are the parameters that we require when we're specifying ride-through. And this basically determines what type of energy storage you're going to be looking at also. The AC line voltage is important. It varies throughout the world. We know US applications are pretty much always 460 to 480 volt. We react to the threshold of the DC bus, which is a direct correlation to the AC line voltage, and we set the ride through to turn on at a certain threshold in relation to the AC line voltage, which controls the DC bus voltage. So it's important that we know the AC line voltage, but we pretty much, if we know the area it's coming from, that's not a real issue. The drive horsepower or kilowatts, and the sag depth or outage times. Those are the main parameters. We'd like to know the drive make and manufacturer, but it's not, a showstopper. DC bus connections are, for the type of UPD products we provide, we have to have DC bus connections. And then we will also help you consider control power. We have control power sag or outage options. You can hold up the drive bus all day long, but if the control power is killed or your PLC network drops out, then everything's gone anyways. So control power is always a consideration when you're backing up VFDs also. Currently the solution is a small UPS, but we do have some options for 24-volt control power backup. So that's always a question you ask that may save you some heartache later on. And then what type of enclosure or configuration do you want? We provide two versions: integratable modules, which if you look at the small blocks, the colored blocks to the right, those actually represent the integratable modules, and then the yellow border around it is the full UPD system. Now another way to possibly save a customer some money is, can the drive share a common bus? We can provide one ride-through rated for a full common bus with multiple inverters. We just have to know the size of the total amount of kilowatts required to hold up all the inverters on the bus. And are the drives in the same cabinet, in close proximity, and evenly sized is a consideration. Loaded drives on the same AC line feed can be diode coupled. In other words, we'll tie the drives together at the inverter sections to the ride-through, to the single ride-through unit. If you're using sag ride-through, all of the drives need to be on the same AC line feed. It's kind of common sense. We're taking the remaining AC line and using it to boost in the top configuration that just has the blue box highlighted, the voltage regulator, and that's just sag solutions. So all of the drives must be on the same AC line feed, especially if you're using the sag ride-throughs. Now, how do we choose the actual units? How do we rate the units? And this is going to tell you pretty much which model number to look for, or which UPD system number to look for. This chart here. On the left is the sag protection ride-throughs, the M3460 Rs or the M3534Rs. The numbers I have up there are the systems, the S3460 SR. If it's got an S in front of it, it's going to be a full cabinet system. If it's got an M in front of it, it's just the voltage regulator booster module. You look on the left side of the chart, and that shows you that we size things kilowatts to time. The sag ride-throughs are pretty much all 2-second sags and below. They'll handle any sag time 2 seconds and below. So you have one standard time for the sag ride-throughs, 2 seconds. 60% sags, all three phases cumulative. Then you look on the right, and then we talk about the outage protection ride-through. Once again, selected by kilowatt and time. The times may shift a little bit because we're doing more with ultracaps. We can do up to 5 seconds by using the battery booster with the ultracaps. But for the most part, most of the ultracap solutions are 2 seconds or less, and we'll use the sag voltage regulator booster that has the time limit of 2 seconds. So basically we take the sag ride-through on the left, and we add energy storage, and then we have the S3460 URs, which are ultra caps, and the S3534 URs. And those can go up to 2 seconds if you're using that booster. Anything between 2 seconds and 5 seconds, we'd have to use the battery booster with ultra caps. Anything greater than 5 seconds, we would use the battery energy storage. So as I said, there needs to be some modifications to this chart as we go along, and as we increase the time for ultracapacitor energy storage. We started at 2 seconds, now we're up to 5 seconds. I think as the cost of ultracaps goes down, we'll probably increase the time also. Now you have display options for all of the ride-throughs. All the display options here apply to every version of ride-through we have. It's all the same display. It just will display somewhat different parameters for some of the different configurations. On the left, you have the DD4 digital display. The digital display is almost a power quality monitor. It doesn't indicate power factor or anything like that, but it will tell you when you have a ride-through event what the voltage was and how long your ride-through event was, and it will log that. You can look at ride-through event records from the factory all the way up until real time, or you can set it to look at a time period. It will also record the 30 most recent fault states. There's a test initiate feature to where you can test the ride-through online. You don't have to disconnect it, you don't have to do anything or turn the equipment off. All it does is boost the DC bus up a small amount, less than what the overvoltage level is to trip the drive, and that just shows that the ride-through is functioning and boosting, and it will be ready for the next ride-through event. There's a threshold check. You can look and see what the threshold is. That means the ride-through turn on DC bus voltage and DC bus voltage fault logic. So in other words, it will indicate faults, and also the LEDs will indicate that too. Then there's a configurations menu where you can set the time and set the status timer. Now on the right is what we have for an analog display. The standard is the DP10, and it has the all the indicators: ride-through ready, ride-through ready, pre-charge complete, ride-through active, and this will show you the unit status, and it will show you some of the functional features as when it's actually doing a ride-through or dealing with ride-through. Your active ride-through event counter is to the right, and then you also have some options, meter options that we can provide, which is the bus voltage and the bus current, and you can add another counter to it which will indicate amount of ride-through events during a period of time. Now first we're going to look at the SAG ride-through, talk a little bit about that, and once again we look at 40% remaining, all three phases for 2 seconds. And if you look at these, are all the blue dots are recorded events, so you can see that the majority is greater than or the SAGs that you see are no less than 60% or 40% remaining. So this does cover a great majority of the SAGs, so this may be an option that maybe who you're talking to, whatever critical application you're working on, customer may start with a full outage and then realize that if they cover the SAGs, that would be more cost effective to the amount of downtime or events they're having. So there's a few things to consider when you're specifying what actually the customer needs. So hopefully they've done their homework, but that's not always the case. Certain industries have certain sag or ride-through specifications. An example of this is the Semi-F47, which means that the ride-through has to be able to ride through sags greater than 200 milliseconds, 2 phases. Well, we cover that above and beyond, and as we do with most of the industry specs. All of the ride-through products are UL. The battery ride-throughs are CE and UL and CUL. And we do look at other industry specs. Actually, the Ultracap ride-through was initially designed for the power vaccine that Samsung requires. So they go above and beyond Semi-F47 in a lot of the Samsung fabs. They have to be able to cover a full loss of AC line for 1 full second, or they won't let you, they won't use your product in the plant if it won't do that. This is the testing criteria, real briefly. This only applies to Semi-F47 semiconductor. Surprisingly, I have had some requests for Semi-F47 certification outside semiconductor. It's a third-party certification, so it does speak to the capability of the ride-through. You have to have it tested, and you have to have it certified. But these show the 3 points that they test for Semi-F47, 50% sag, 10 cycles, 70% sag, 20 cycles, and 50 cycle, 80%. Or actually 80% remaining, 20% sag. Now, talking about the sag ride-through, which is just the voltage regulator booster, is the solution. That's the total solution for this. It can either come, as the pictures show on the right, as an open chassis unit you can put in the drive cabinet, or we can actually put a full enclosure around it. And the benefit of this is it applies, or it provides a disconnect between the actual ride-through and the drive connections. So that's one of the reasons that we'll put one of these in a cabinet, because that's pretty much the only extra thing inside the cabinet is the open chassis unit, the DD4 display, and the disconnect. So that would be the advantage of that. But otherwise, this unit's fine by itself. It can go in a drive cabinet if there's room. And we pretty much covered the specification here. So moving right along. This shows the connectivity. As you can see, simple connections, 5 connections for the sag ride-through. You have 3 AC line and 2 DC bus. That's pretty much it for the 3534s and the 3460s. This shows a picture of what the sag ride-through cabinet would look like, and on the right you can see the DP10 display with the 2 analog meters. The digital display would replace that for most of the applications we deal with. And once again, no external energy storage is required. Single unit will cover this specification. And you can do multiple VFDs, multiple inverters with 1 ride-through unit. And this pretty much, that's pretty much it for the sag ride-throughs. I would like to point out that 1 unit can do up to 250 kilowatts at 460 volts AC. We can do master-slave configurations, and we've gone up to 1,000 kilowatts. That requires a master control module, and then you would use the same open chassis backplates as power modules. Now we're moving on to short-term full outage ride-through, and first thing I wanted to put up was this is the spec that actually motivated us to use the Ultracap energy storage, which is the 1-second power vaccine that you're going to see with the Samsung fabs. Don't need to go into too much detail with that. But now when we're talking about full outage ride-through, we're taking the ride-through voltage regulator booster and adding the units, the components, the modules, and the energy storage that goes with it. Because as you recall, with the SAG ride-throughs, we were using the remaining AC line. That was what was providing our power to the DC bus through the ride-through voltage regulator. But now we're adding energy storage to it, so we're going to be getting our DC bus voltage to hold up the DC bus from the energy storage bank through the voltage regulator booster. And the three types that we use currently, for very short-term, low kilowatt applications, we can do electrolytic capacitors. We say up to about a half a second, less than 15 kilowatts. That's the most economical energy storage for that type of a specification. Then if you recall, with the SAG ride-throughs, we can add ultracapacitor energy storage. And once again, we're not using the AC line anymore. We're using the ultracapacitors with the same SAG ride-through booster, which gives us 2 seconds of full outage or full loss of AC line. And then after we get up above 5 seconds, because what we do in between the using the SAG ride-through booster and jumping up to battery energy storage is we'll use ultra caps from 2 seconds to 5 seconds with the battery booster. That's something new we started doing this last year because of the cost of ultra caps going down. So now we can offer a little bit more time with the ultra caps. And with batteries, we say up to 15 minutes, but I actually quoted 4 hours last week. So time is pretty much unlimited, but when you get up past 15 or even 30 minutes, the cost of the batteries and the weight of shipping and all the logistics issues that go with it, service contracts, battery maintenance, the cost gets pretty extensive as compared to what the same type of issues would be with the UltraCap energy storage. There's no service contract with UltraCaps. They have a much longer life than batteries, so that's why we try and, promote the UltraCaps as much as we can. But as I said, 5 seconds right now is the time that we see as being UltraCap economical. But those are the three types of energy storage we're using right now. Batteries can also include NiCads and lithium if that's what the customer wants, but the customer will have to provide anything else other than valve-regulated lead-acid batteries. Now, as far as the configuration of the short-term outage, which is half a second to 2 seconds, using the SAG voltage regulator booster, on the left it shows a 60 horsepower, 1 second full AC line loss, and the UltraCaps are included in the cabinet. So in some instances we can provide one cabinet that has everything in it, but then you get upwards past 50 to say the 250 kilowatts, then usually one bay will contain the energy storage, as you see in the example at the bottom of the page, and the other side of the cabinet, or another cabinet that doesn't necessarily have to be connected, will include the electronics components. 2 seconds to 5 seconds, 100% three-phase outages. And the only difference is up to 2 seconds we use the SAG booster. From 2 seconds to 5 seconds we can use the battery booster. And don't get confused about the term because we're using it with UltraCaps. Once again, on the right, the colored blocks show the modules that go within the UPD cabinet system. We can provide modules or we can provide the full cabinet system. This shows the layout of a capacitor system, ultracapacitor system. Isolation transformer is connected to the AC line. The isolation transformer is for the charger, and the charger is connected directly to the ultracaps. The ultracaps are connected to the voltage regulator booster, which ties to the drive at the DC bus terminals. So as with the SAG, when you're just using SAGs and using the AC line to boost, you would have to have the AC connection to the voltage regulator booster, but as you can see, it doesn't connect to the AC line except through the charger and the isolation transformer. And with UltraCap energy storage, these are roughly rated in farads, so it can take a long time for them to just bleed off. So we provide a discharger that will immediately discharge the cap bank in the event of maintenance, or you have to get into the cabinet for one reason or another. This slide here shows the components mounted in the cabinet in more detail. Once again, connects to the drive's DC bus terminals. It will protect SAGs up to complete outages even though you're using the energy storage. You don't have to have a SAG ride through and a full outage ride through. This will protect from anything less than up to what it's rated for. The energy storage is provided by Bonitron or sourced locally. We, like with UltraCap solutions, we really would like to provide the energy storage, but if the customer is adamant about having a good UltraCap connection, then we'll look at the specification of the caps they're using, make sure they're going to work with our system, and we do leave that option open to the customers to source their own energy storage. Once again, on the right-hand side, you see the components: the discharger, which discharges the caps, the charger, and the voltage regulator booster. It will either be the 3534R or the M3460R. On the left is the UltraCap energy storage. Now we're going to move into long-term outages, full loss of the AC line for a long period of time. 5 seconds is where we do the cutoff of the UltraCaps, up to 4 minutes plus. As I said, we've quoted all number of different times. And this is 100% three-phase outages. That means the AC line's gone. You're using battery energy storage, and so it's ideal for dark starts or to maintain process before the generator starts up, because most generator startups are greater than 5 seconds. So you may have to use a little bit of battery there to get them through the utility power out to gen set up. This lays out the battery system. Not much different than the UltraCap system. As you can see, there's an isolation transformer, the same charger. We would connect the charger to the batteries connected to the voltage regulator booster, which is connected to the DC bus of the drive. So you're pulling energy out of the batteries and you're providing it directly to the DC bus through the voltage regulator booster. A little more detail about the battery system and the batteries, the actual batteries that are used. Once again, we call this long-term outages. As the same with all the other ride-through type configurations, it's sized by time in kilowatts. Usually, we're going to look at the DC bus, and for a 480 volt AC system, or 433 to 480 volts, we're going to use the 480 volt DC bank, which is 40 12 volt batteries. There's some issues with battery energy storage. The cabinet has to be have proper venting. The person that's putting together the cabinets, because we do offer the modular type solutions and we will provide batteries, but the customer should know a little bit about how to mount batteries and the proper venting in the battery cabinet. So that's the option. If the customer wants to provide their own batteries, they may have a good battery connection, as long as we can review the battery spec and make sure they know what they're doing when they're putting them in a cabinet. One advantage to our type of configuration is with a UPS, you have a series solution, so it's constantly providing the AC to the front end of the drive. So that means the UPS is constantly active in one way or another, and so that will cause wear and tear on the batteries over a period of time. With us being a parallel solution, we're off until the DC bus tells us to turn on, then we pull from the batteries. So usually battery vendors will tell you 5-year battery string change outs. My experience has been 2 to 3 years. When I walk into a plant and they've been using a UPS or some sort of a battery type backup, they tell me they've been changing them out a lot quicker than what the battery vendors say. If you do have a customer that wants to use their own batteries or their own energy storage, we can provide battery bank specs. Okay, I have a question here. Let's see, we talked about low horsepower drives and high horsepower drives for SAGs. Yes, it is a cost issue because you want to size the actual kilowatt requirements of the motor to what you actually have to provide during a ride-through event. One thing I probably should have pointed out is that it's mainly a difference between the M3534Rs and the M3460s. The M3534Rs are up to 50 kilowatts, the ones in the small blue boxes. And anything greater than 50 kilowatts would be the M3460Rs. So the cost consideration is if you can get the customer into a smaller 3534, which matches up whatever kilowatt requirement he is, that would definitely be a little more cost effective than oversizing or doubling the requirements. Say if he has a 12 kilowatt requirement, you use a 50 kilowatt 3460, then that's definite overkill. So that's the consideration there. Okay, battery energy storage considerations. Now, a couple things that I think after dealing with a lot of end users' aggravation with batteries, some of the things that I find is once there's a battery service contract in place or there's a battery maintenance program in place, it really depends on who's running it and what type of service they're using or who they're using for the service. I found that you walk in, they want to know why the UPS didn't work. Well, you go and find out that the battery maintenance wasn't carried out. There's dead cells because a UPS or backup is only considered when there's a problem. And if the customer goes on for months and months and months without an event, then possibly they haven't maintained their backup system properly, especially in the case of batteries. Maintenance personnel change. The guy that was really diligent about the batteries, well, he left, and then all of a sudden there's a new guy in there, and it's not being looked at correctly, and then an event happens, and the batteries aren't there. So that's why a battery service contract is very important with the battery ride-throughs. If there's batteries involved, there has to be some sort of a maintenance contract or program. Bonitron doesn't provide that, but the integrators we work with and possibly the drive manufacturers will provide that too. In some cases, what happens is the drive manufacturer installer also takes on the responsibility for the Bonitron products, because we have a service department and we will go to a site to deal with a problem or issue, but we don't provide battery maintenance or battery service contracts. So that's something that needs to be in place if that's the type of solution that you're dealing with. This shows a battery cabinet along with the electronics bay next to it. As I said, especially with batteries, the batteries will come or can come in their own separate cabinet, and that'll include a disconnect and the mounting. They'll be mounted and wired, and it will connect to the electronics bay, the charger. And as you can see on the right, for a battery solution, it's only a charger, a voltage regulator, and the isolation transformer for the charger, plus the disconnect that disconnects the drive and also disconnects the system from the batteries. And there's a battery disconnect too. And once again, any of the ride-through solutions can provide backup for multiple drive common buses. There is no discharger required in here. I know that's kind of common sense, but I still put it out because I get the questions. That is that breaks down the three categories of ride-through that we provide. Now we have some general installation considerations. We've covered a lot of this, but now we're going to kind of summarize it, and then I'm going to talk a little bit about some applications, and then we'll wrap it up. Okay, for all the ride-through types that we talked about, some of the general rules are the size of the ride-through depends on the kilowatt and the energy storage. Full cabinet systems or modules, any UPD product we provide, regardless of specification, has the option of being provided in a module form or a cabinet system. Now, one thing to consider is the modules will require integration, and the cabinet will have to be provided by the end user. It's still not that complicated. Everything connects together by terminal connections. It's still, even if you do the modules, it's not a very difficult thing to integrate. It's just providing the proper cabinet that can fit everything in it. Once again, you're going to have an isolation transformer with any of the energy storage type solutions, except some of the smaller electrolytic caps, where we just use electrolytic caps on the bus with a booster. And of course, you should ask the question. Most times I've found that there's a drive specialist involved, and he's already covered the control power. But we do have those options. We can provide AC or DC backup, SAG, or full outage control power backup. This is for the PLC networks, controlling the process, controlling the drive parameters also. So it's critical that this is backed up also. So it's just a question, hey, what kind of control power are you doing? Usually that's covered, but you still should ask the question. And then what type of environment is the ride-through going into? Sometimes we've run into having to derate things that are maybe up on a mountain somewhere. There is some elevation derate or temperature derate. And is there a NEMA, is it a standard cabinet, or is there a NEMA 3R requirement? We can do that too. If you're going to install the ride-through in a cabinet with the drive, the watt losses aren't that great, but you should consider it if the drive cabinet's already pretty tight. The drive's going to have some heat, so the ride-through will add to it about the same amount as the drive. So it's just a consideration. And then energy storage and the type of displays. And that's pretty much the general things for the for any of the ride-through solutions, and we can take most of that information and hammer it into a solution for an end user. Now a little bit about ride-through master slave, and What you're doing basically is you are taking several ride-through backplates, because as I said, the ride-through kilowatt ratings for the single 480 volt unit, 480 volt AC line, is going to be 250 kilowatts. Anything greater than that, we have to apply multiple power sections, and there has to be a control module. The control module is the same for all kilowatts. It just controls the ride-through open chassis backplates to be able to provide consistent and balanced power to the DC bus. Now, we have run into one issue one time in the whole time I've been doing this stuff for 16 years, but it's just a heads up, but it's not a requirement. We had an application in Singapore to where they were seeing, and we think it was because of the way they were configured, but we still provided a diode plate. So there are some instances which are extremely rare. I just wanted to point it out in case you run across it. But I really don't think that's going to happen. That you may need to isolate the parallel power modules with a diode board, and that's only in the SAG ride-throughs, and it's only been one instance that we've run across that. But for the most part, you're going to have one controller, and you're going to have several parallel power modules, and right now we've gone up to 1,000 kilowatts with the parallel power modules, but we can do more than that. So that's all we've been requested for, was 1,000 kilowatts. Now, when you're applying multiple drives, ride-through to multiple drives on a common DC bus, we have what's a diode board, which includes fusing and diodes that actually protects the VFDs and allows them to all share the ride-through. That's the M3460D. All we need to know to be able to size a common bus ride-through, other than the things we talked about in general earlier, is the number of drives on the common bus. In other words, we would provide a diode board that would connect two drives. We have all kinds of variations. I just quoted a 12 position common bus, ride-through common bus, which is actually two 6-position 3460Ds, or M3460Ds. So in other words, for a ride-through common bus, we would have to know the number of drives and the amp ratings of each drive to be able to size the diodes correctly. We have to make sure that the fuses and the diodes are sized big enough to handle the amps of one single VFD that's going to be tied to whatever leg on the CBM is. Now, where and why do we use ride-through? What do we look for ride-through applications? I put up some of the applications we've done, but this isn't limited to just these. Anything to where the process or the whatever the customer is providing as far as a product, or whatever they're trying to back up for, say, an environmental system. And we look for the critical processes which can have no speed or torque change of the motor. So in other words, it has to have a continuous process. There can't be any interruption or deviation of the drives running the process. Some of the applications that we've done or provided ride-through for, clean room air handling systems. Now, clean rooms are not just limited to semiconductor. There's clean rooms in pharmaceuticals. There's clean rooms in chemical processing. A lot of different industries have clean rooms. But for the most part, it's been semiconductor for most of the clean rooms. Cooling water systems, machine tools, things that such as the machine tools that etch wafers or things like that, or aircraft parts. We've seen a lot of critical applications in. the cooling water that goes to the machine tools. If there's any deviation in the flow, even though the drive rides through, the sensors in the flow line may detect a deviation and then shut the machine down anyways, and the drive may still have ridden through. Synthetic fiber spinning. There has to be a consistent motor speed and torque because it can deviate and cause a scrap product in the synthetic fibers, and you can actually, the motor and the drive may ride through because of something like kinetic buffering, but then that will also cause the fiber extrusion to be non-quality, or what they call grade B scrap, and they'll just have to throw it away. And a whole afternoon in the fibers industry of production can be wasted without possibly the engineers or the maintenance folks even knowing about it, unless they're watching the motor constantly. Turbine lubrication pumps. This has been a big application for us over the past few years. When you're using a turbine, it has to stay continually lubricated, or what happens is the turbine burns up. So we back up the lubrication pumps for the turbines. Oil field extraction pumps. Those seem to be one of the greatest amount of downtimes when the drive fails. It's actually doing the pumping. Say in PCP pumps, things like that, ESP pumps. So, but the key is you must maintain constant power to prevent any downtime or product damages. And here's a listing of some of the critical applications we run into. Data centers has become quite popular over the past few years. They're backing up the cooling, the environmental cooling for the data centers now with VFDs and ride-through. And the solution was UPSs. We've done several data centers. The big thing with data centers is you can't talk about them too much. I found that out the hard way, but okay, moving along. Automotive, those parts can be pretty expensive when they're damaged or there's downtime. You know, the automotive industry is always concerned about downtime. Chemical food processing. We're doing several projects with elevators and escalators, which is more of a safety issue. If you have an elevator or an escalator stop, well, you can kind of figure out what happens. People are stuck, say in a fire or something like that. So, and the solutions out there for emergency backup aren't the greatest in the lift industry currently. Mining, there's a lot of critical processes and in smelting processes, personnel hazards, things like that, to where you can't have any stop in the process. Packaging, pulp and paper, recycling, water, wastewater, centrifuges, things like that. Waste disposal, we've done some nuclear waste disposals, and I think you can figure out why those are critical processes. And security, backing up security gates for high-level type facilities, things like that. So if a lot of these applications are outlined in industry brochures on our website, you can see at the top there's a pull-down menu for industries, and it will actually have a brochure that lays out the type of product, the application, and a little one line about what actually we did for that particular solution. So those are good resources, along with some of the other things we have on the website. So go ahead and if you find anything that that doesn't make sense, or you know, or needs to be edited or updated, please let us know. Okay, where it all began. Bonitron started providing ride-through for the fibers industry back in the late 70s, and pretty much what they found is as I alluded to earlier, was that during the process of manufacturing the fibers, the extrusions, and winding up the fiber, if there's any change in the motor speed, it causes a grade B or scrap product. And in the beginning, there were times to where it would just be running this product, and you can't watch it every second of the day, so they'd find out that they had been running bad product, and they'd have to scrap a whole afternoon of fiber production. So that's where ride-through came about. We were approached by DuPont back at that time, and they wanted a way to be able to ride through the utility power events that were happening, that were causing, say, a small sag that would cause maybe a loss of phase to where the motor can keep running, or the drive could keep running back then when drives weren't quite so high-tech as they are now. So that's where it started, and the ride-through products became popular in the fibers industry, and word got around to other critical applications, and that's where it all took off. Now, some of the applications that we've done, and this basically speaks to the fact that everywhere in the world is going to have a different specification, but usually they're regional specifications. As I said, in the United States, it's mostly sag ride-through, unless you run into a customer that wants to be completely bulletproof, like some of the data centers. They want full outage ride-through for a spec that they've developed themselves, and they don't really care what the utility power is doing. So you'll run into that sometimes too. We say okay to that, and just provide the spec after some education as to what we can do. And if they still want to use the spec that is above and beyond what the utility outages or the utility power quality is requiring, then we'll go ahead and specify that too also. But we do like to offer all the options and let them know what we know about providing the amount of ride-through that's required. This shows the difference in a lot of the third world countries. We'll use full outage ride-through. Ultracaps, this is a half a second ride-through, and it was due to a utility power switchover from plant power to residential power. So they do that at the end of the day. They slam it over. It causes a half a second outage, and that's what we provided Ultracaps for. Now in the United States, once again, 2-second sags. We've done a lot with the fibers industry in the U.S. DuPont, which is now kind of been fragmented. One of them is Corsa that we work with, and that was a 2-second 50% sag that we backed up. We do a lot with critical environmental control. This once again is a clean room, and this basically shows the power layout. You're going to have redundant backup at the utility, but it's still, when something trips, it's going to take a little bit of time, or a second or two, or less than a second, to switch over to an alternative power source and or alternative line. And in a clean room, this can cause a disruption of the fans or the air handlers, and the environment has to stay so pristine that, for example, if you were to take what they measure as far as a particulate on the filters as being as corrupting the air in, say, wafer clean room, they will cross-section a human hair, and about 1/10 of that is a particulate that they're looking for, to where they would just trash everything in the clean room, meaning it's been corrupted. You can't have anything that gets into the wafer manufacturing, or it will cause problems with the chips when they package them later on. That's the air handlers and the filters that actually keep the environment of the clean room pristine. Also, the chillers, the temperature in the clean room also has to be rock solid. Any temperature deviation can cause problems with the wafer etching also. Or say in pharmaceuticals with the chemical processes, or sometimes they're working with hazardous gases or hazardous materials, so ventilation is critical too in a lot of clean rooms. And with a lot of these critical applications, you're going to have what I talked about earlier, which is redundancy. You're going to have a UPS, it's backing up the distribution point, but this does not cover process level problems too. So even though you got the utility covered into the plant with a UPS, there may be internal plant things that happen, load shifting, failures in other lines, other clean rooms that cause a problem with the power. So that's why at the process level, the drives are backed up. At the distribution point, the drives are backed up. And a lot of times you'll find a gen set that backs it up too to make the system completely bulletproof. This was a Samsung project we did, 1 second outage. As you can see, we provided 2 different bays, one with the energy storage and one with the electronics. So the voltage regulator, booster, charger, discharger, and the ISO transformer in the electronics bay. Energy storage is in the other one. This was for process cooling water. And it was 1 second full outage, which is the Samsung power vaccine. Now we're back to the SAG ride-through, and this was, as a matter of fact, most of the Intel installations we did were all SAG ride-throughs. So in Israel, Costa Rica, and Chandler, Arizona, that was all SAG ride-through. Freescale in Chandler, Arizona is also SAG ride-through, but it was a lower kilowatt, less than 50 kilowatts. So now this, we don't care about the name of the end user, we care about the type of application. These type of applications are all over the United States. I know in upstate New York, we've been working with a lot of the semiconductor fabs up there, and hopefully there'll be more opportunities to come there as they develop their Silicon Valley North is what I call it. This shows the 90-second full outage, which was batteries in Taiwan, and then Singapore was Global Foundries, and this kind of relates to the U.S., and this is what I found is so interesting, is that in Singapore, they were using SAG ride-through, which is a single unit with the drive, but in upstate New York, they were using 1 second full outage, which is usually backwards. Usually in, the overseas, they use the outage ride-through. In the U.S., they use SAG. So depends on what the customer requires. Okay. Okay, we're getting ready to wrap this up here. Critical environmental control. Once again, this shows the layout of the what usually you're going to find in a plant. But now we're talking about data centers. What we're doing is we're backing up the drives, the air handlers, the chill water, cooling tower drives, anything and everything is tied on the common bus. And we'll put one UPD system on a full data center HVAC system. Okay, and some of the other miscellaneous applications real quick because I'm running out of time here, or ran out of time already. This was a Venezuelan project that we did, half a second. One thing to note here, this was UltraCap ride-through for half a second. The return on investment was 2 months at $50 a barrel. So they're out there. These applications are out there. This was a progressive cavity pump. And this shows the lineup for the turbine lubrication pump, which was battery ride-through. It was on the drive that was backing up or that was running the turbine lube pumps. This specification, we've done several of these, and the specification varies. There's no real guidelines to it. Just in summary now, yes, it's the home stretch. This shows the 3 configurations, and this shows a little guideline as to what you look for. I'm not going to read through it. We've already been through it in detail. And this is some of the different options and configurations we've done, and it shows the UPD display options also. So this is a good resource for later on. Okay, here we're looking at the manual for the ride-through, and we're almost finished. This shows the specification for the ride-through, so the manuals are pretty extensive, and there's a lot of good resources on the website. Each product has its own product page, and there's a full product page for all the undervoltage products that break it down into the type of product or the module. And that's all I have. Thank you for tuning in. And if you have any questions or comments, please feel free to forward them to me. And everyone else have a good day.